Dear students, welcome. This is your 9th class on statistics. Today, we shall try to solve some problems. 3 questions have already been written here. First, I shall try to answer the question number 1. What is it? Forces PQR act along IA, IB, IC, where I is the incenter of the triangle ABC. I is the incenter of the triangle ABC. Let me write like this. Like this. ABC is the triangle. I is the incenter of the triangle. I is the incenter of the triangle ABC. And are in equilibrium along IA, IB, IC. IA, IB, and IC. This P force, Q force, and R force. I is the incenter of the triangle ABC, means I is the center of the circle. And 3 forces P, Q, R are acting along IA, IB, IC respectively. And are in equilibrium. Then we have to show that P is to Q is to R is equal to this. You see, since the forces PQR, since the forces PQR acting along IA, IB, IC respectively, acting along IA, IB, IC respectively, are in equilibrium. Therefore, by Ramen's theorem, we get what is Ramen's theorem? If 3 forces acting at a point be in equilibrium, then the magnitude of each force is proportional to the sine of the angle between the other two. Magnitude of the forces P, sine of the angle between the other two, sine of the angle BIC. This is equal to Q divided by sine CIA. This is equal to R divided by sine of AIB. By Ramen's theory, we get this. Since 3 forces acting at a point, 3 forces PQR acting at the point I are in equilibrium. Therefore, by Ramen's theorem, magnitude of each force is proportional to the sine of the angle between the other two forces, between the other two, BIC. Suppose this is number 1. I am writing here, this is number 1. Now, generally, in a triangle ABC, the angle A, we know this angle is equal to angle A. Angle A means this one, this angle. The interior angle BAC will BAC. This angle will mean angle A. Angle A means BAC. And CA BIC, BAC, ABC, ABC, what is ABC? ABC means angle B, the interior angle, and angle ACB means angle C. Now, IA, IB, IC divides the angle A, bisects the angle, divides the angle A into two equal parts. Means IA, IB, IC are the bisectors of the angle ABC, respectively. Now, IA, IB, IA, IB, and IC are bisectors of the angles AB and IA, AB and C, and C respectively. This means that, therefore, this means that, therefore we get IBC. What is angle IBC? IBC, this is equal to half of ABC, half of the angle ABC. This is equal to half of angle B, half of B. ICA, ICB, this ICB, this angle will be equal to half of ACB, half of angle ACB. This is equal to half of angle C, half of angle C. Now, from the triangle IBC we get, now from triangle IBC, from triangle IBC we get, now from the triangle IBC we get angle BIC plus angle IBC plus angle ICB equal to 180 degree. Sum of the interior angles of a triangle is 180 degree. This means BIC, angle BIC plus IBC means half of B. You may write half of B. ICB means half of C equal to 180 degree. This means that angle BIC equal to 180 degree minus B plus C divided by 2. You will get this one. You will get this one. This means, let me write here. This implies BIC equal to 180 degree minus 180 degree minus A. You may write, yeah, 180 degree minus A. Since A plus B plus C equal to 180 degree, since the sum of the interior angles equal to 180 degree of a triangle 180 degree, you will get this one. This is equal to 180 degree minus 90 degree minus A by 2. 90 degree minus A by 2. This is equal to 180 degree minus 90 degree plus A by 2. This is equal to 90 degree plus A by 2. 90 degree plus A by 2. Angle BIC equal to this. Similarly, angle, you see, angle BIC equal to 90 degree plus A by 2. Similarly, angle CIA, if BIC equal to 90 degree plus A by 2, CIA will be 90 degree plus B by 2. And angle AIB will be equal to 90 degree plus C by 2. 90 degree plus C by 2. Therefore, from 1 we will get. From 1 we will get P divided by sine it will be 90 degree plus A by 2. This is equal to Q by sine 90 degree plus B by 2. This is equal to R by sine 90 degree plus C by 2. C by 2. From 1 we will get this. What is 90 degree plus A by 2 sine? This means it will be cos A by 2 equal to Q by cos B by 2. This is equal to R by cos C by 2. Therefore, P is to Q is to R equal to cos A by 2 is to cos B by 2 is to cos C by 2. C by 2. P is to Q is to R equal to cos A by 2 is to cos B by 2 is to cos C by 2. Therefore, we have proved the number 1. I is the incenter of the triangle ABC. IA, IB, IC will bisect the angle ABC respectively. This is the theory. And from Lami's theorem, if three forces acting at a point are in equilibrium, then magnitude of each force is proportional to the sine of the angle between the other two. This is Lami's theorem. We have proved number 1. Let me prove this. We have proved number 1. Now, let us try to prove number 2. What is this? Forces PQR act along OA, OB, OC, where O is the circumcenter of the triangle ABC. Now, O is the circumcenter of the triangle ABC and are in equilibrium. And are in equilibrium. O is the circumcenter. O is the circumcenter of the triangle ABC. You see, I may write the diagram here also. Suppose this is the triangle, this is the circle ABC. ABC. O is the circumcenter of the triangle. OA, OB, OC. Forces OA, OB and OC are acting PQR acting PQR are three forces which are acting along OA, OB and OC respectively. O is the circumcenter of the triangle ABC and are in equilibrium. Therefore, you can apply Lami's theorem. Since the forces acting along OA, OB, OC are in equilibrium, you can apply Lami's theorem. Yeah, since the forces, the answer should be like this. Since the forces PQR acting along OA, OB and OC, OA, OB and OC respectively, and are in equilibrium. Therefore, by Lami's theorem, we get what we will get? Magnitude of each force is proportional to will be proportional to the sine of the angle between the other two forces. P divided by sine BOC, this angle. Q divided by sine COA and R divided by sine AOB. R divided by sine AOB. Magnitude of each force will be proportional to the sine of the angle between the other two. Now you see. This is the center. This is the center. From geometry, you will get under this, you will get in the center this angle will be equal to 2 times of this angle. If the triangle is like this, then also the angle made in the center will be equal to this angle. Any triangle, for any triangle, this is center O. This angle under this chord, this angle will be equal to 2 times of angle this. From geometry of high school level. You will get this one. Therefore, I am going to apply this. This implies that P divided by sine BOC, what will be BOC? BOC equal to 2 times of angle BAC. This implies sine of twice A. 2 times of angle BAC means twice A. Because in triangle ABC, this angle is BAC will denote it by A. The angle ABC, this angle, it is simply, we write simply B, and angle BCA, we simply write this angle C. Instead of writing BCA, we write angle C. A means you will get this angle. A means you will always mean BAC, angle BAC. Now, P divided by sine twice A. Here you see. Q divided by COA. Under this chord, you see. It will make here the angle COA and here it is angle ABC. This means that it will be sine twice B. From high school geometry, this is equal to R divided by sine twice C. You will get this. It is very simple. The first one has been proved. That is P is to Q is to R equal to sine twice A is to sine twice B is to sine twice C. Number 1 has been proved. Now from this you may write P by 2 times of sine A into cos A equal to Q by 2 times of sine B into cos B. This is equal to R by 2 times of sine C into cos C. You will get like this. 2 will be cancelled from this. P divided by sine A. You know that A by sine A equal to B by sine B. I am writing here so that A by sine A equal to B by sine B equal to C by sine C. This is equal to twice R. From trigonometry, you get A by sine A. Small a means the side BC of the triangle ABC. B means the side CA. And C, small c, will definitely denote the side AB of the triangle ABC. In place of twice R, here R is already here. Therefore, let me write here K. This is equal to K. Therefore, sine A will be equal to A by K. You may write here A by K. For cos A, you may write b square plus c square minus a square divided by twice bc. The trigonometrical relation. This is equal to q divided by, what is sin b? B by k. Actually b by twice r, you may write twice r also. This twice r will be cancelled. You may write twice r, you may write k also. Here already r is there, therefore I am writing k. Then you may write twice r also. Write twice r. A by twice r. B by twice r. Cos b means c square plus a square minus b square divided by twice ca. Divided by twice c. This is equal to r divided by c by twice r. A square plus b square minus c square divided by twice a. Divided by twice a. You will get like this. Twice r cancel. 2 will be cancelled. From each side. This means p divided by a, this bc will go to outside to numerator, a into b square plus c square minus a square. This is equal to ca q divided by c square plus a square minus b square into b. This is equal to abr c into a square plus b square minus c square. You will get this one. You will get this. This means multiply both sides by a. Numerator by a and denominator by a. You will get this one. This is equal to multiply both sides by b, not both sides, numerator and denominator by b. You will get this b square, c square plus a square minus b square. This is equal to multiply numerator and denominator by c. You will get this one. You will get this one. Here multiply both sides by a, not both sides, I am sorry, multiply both sides numerator and denominator by a. Here multiply numerator and denominator by b, and here multiply numerator and denominator by c. Then divide by dividing by abc, you will get, divide by abc, you will get a square, b square plus c square minus a square. This is equal to q, b square, c square plus a square minus b square. This is equal to r, c square, a square plus b square minus c square. You will get this. This has also been proved. That is p is to q is to r. This is equal to a square into b square plus c square minus a square is to b square into c square plus a square minus b square is to c square into a square plus b square minus c square. You will get this one. Now sometimes here divide by a square b square c square. From this, no, I am writing here, no. Divide this by a square b square plus c square minus a square divided by a square b square c square. This is equal to q b square into c square plus a square minus b square divided by a square b square c square. This is equal to r divided by c square into a square plus b square minus c square divided by a square b square c square. You may write like this. Now this a square will be cancelled, this b square will be cancelled, c square will also be cancelled. Now what is this? B square plus c square plus minus a square divided by b square c square. it can be written as b square by b square c square means 1 by c square plus c square by b square c square means 1 by b square. This means that you may write here p by 1 by c square plus 1 by b square minus a square by b square c square. You may write like this. This is equal to q divided by this c square will be cancelled 1 by a square plus 1 by c square minus b square by a square c square. You may write like this. Or, and finally, a square by a square b square means 1 by b square. 1 by b square plus 1 by a square minus c square by a square b square. You may write like this also. From this, you can conclude that in this case, P is to Q is to R. This is equal to 1 by c square, b square plus, right, b square plus c square minus a square by b square c square. This is to 1 by c square plus 1 by a square minus b square by a square c square is to 1 by a square plus 1 by b square minus c square by a square b square. You may write in this way also. You may write like this also. Sometimes you may be asked to prove that P is to Q is to R is equal to this. Therefore, question number 2 has also been answered. It has been, the problem has been solved. The problem has been solved. Now, question number 3. What is question number 3? You see, 3 forces PQR act perpendicularly to the sides BC, CA, AB of a triangle ABC at their middle points D, E, F respectively. All inwards or all. Now let me write the triangle. This is the triangle ABC. Suppose ABC is a triangle. PQ are acting BCCA perpendicular to BCCA AB of a triangle ABC at their middle points D, E, F. Suppose this is the middle point. These are the middle points. Middle D, E, F. This is F. Such that the magnitude of the forces are proportional to the length of corresponding sides. Act perpendicularly. Perpendicularly means, suppose BC, P force is acting along this, Q force is acting along this, and R force is acting along this. As shown in the figure, D, E, F are the middle points of BC, CA, and AB respectively. And you are also given that the magnitude of the forces are proportional to the length of the corresponding sides. Magnitude of the forces are proportional to the length of the corresponding sides. Length of the corresponding sides. Prove that the forces are in equilibrium. Now, the 3 forces P, Q, and R are acting along OD, OE, and OF respectively. respectively. Given that P divided by BC equal to Q by C, this is equal to R by AB. This statement is given in the question. Their magnitudes such that the magnitudes of the forces are proportional to the length of the corresponding sides. This means P by BC is equal to A. CA means it is B. R, it is C. It will be C. Now, A by sin A equal to B by sin B equal to C by sin C equal to twice R. For twice R, that's right K, because R is also already here. This means A should be equal to K into sin B equal to Q into K sin B equal to R K sin C. This means that P by sin B equal to Q by sin B equal to R by sin C equal to R by sin C. P by sin A equal to Q by sin B equal to R by sin C. Now, thus notice the diagram. This angle is 90 degree. It is given in the question. This angle, this is also 90 degree. It is a quadrilateral. AFOE is a quadrilateral. Some of the interior angles will be 360 degree. 90 degree, 180 degree. If you minus 180 degree, then sum of this and this will be equal to 180 degree. Sum of the angle A and angle this equal to 180 degree. Therefore, you will definitely get P by sin 180 degree minus. This angle is A. What will be this angle? EOF. EOF. You will get EOF. This is equal to Q divided by sin. For angle B, you see, this angle is 90 degree, this angle is 90 degree, 180 degree, this plus this plus this plus this equal to 360 degree. Mean this is 90 degree, this is 90 degree. This means that this plus this is equal to 180 degree. What is angle B equal to? What is angle B? Angle B will be equal to 180 degree minus this angle. 180 degree minus FOD. FOD, this angle. This is equal to R divided by sin. R divided by sin. This R divided by sin. This is 90, this is 90. C plus this equal to 180 degree. What is C? 180 degree minus DOE. 180 degree minus DOE. 180 degree minus DOE. This means that P by sin EOF equal to Q by sin FOD equal to R by sin DOE. R by sin DOE. Now notice the diagram. P by sin of this angle, Q by sin this angle, R by sin this angle. This means that the forces P, Q, R are acting in such a way that their magnitudes are proportional to the sine of the angle between the other two. Therefore, by converse of Leibniz theorem, the three forces must be in equilibrium. This means that This means that the three forces P, Q, and R are acting at O along OD, OE, and OF respectively in such a way that the magnitude of each force, the magnitude of each force is proportional to the sine of the angle between the other two. Hence, by the converse of Lami's theory, we get we can say that the three forces P, Q, and R, are in equilibrium. Hence, by the converse of Lami's theory, we can say that the three forces P, Q, R are in equilibrium. Therefore, we have proved the question number 3 also. Let us try to solve this another problems. Let us try to solve. First, let me remove this one. Now, let us try to solve these two problems. See question number 4. Today's question number 4. A string ACB has its extremities tied to two fixed points A and B in the same horizontal line. To a given point C, AB are 2 points in the same horizontal line. And this point is C. It is not a given weight W. A weight W is here. This is the weight W here. AB is horizontal. We draw another horizontal line here. This line is also horizontal. You see, AB is horizontal and this line is horizontal. What does it mean? These two lines are parallel. Therefore, this intersects. Transversal is this. Therefore, this angle will be equal to this angle. In this way, these two parallel lines, AC intersects it. Therefore, this angle should be equal to this angle. Suppose this angle is this. This angle equal to this angle, and also this angle is equal to this angle. Right? Now, prove that the tension of the portion CA. Suppose this is T1. Tension. This is T2 tension. Let T1 and T2 be the tensions of the portions CA and the CB respectively. Now the three forces T1, T2 and W are in equilibrium. Now the three forces T1, T2 and W acting at C are in equilibrium. Therefore, by Lami's theorem we get what we will get? T1 divided by magnitude of the force T1 divided by the angle between this and this. What will be this angle? This angle is equal to 90 degree. 90 degree plus this. What is this? This is nothing but B. 90 degree plus B. Sine of 90 degree plus B. This is equal to T2 divided by sine this angle. What is this angle? Since this is 90 degree, this plus this is equal to A. 90 degree plus A. Sine 90 degree plus A equal to W divided by the angle between this and this. It is C, sine C. You will get this one. This means that T1 divided by, it is cos B, cos B, this is equal to T2 by cos of A equal to W by sin C. The tension of the portion CA, we have to find the tension of the portion CA. Taking the first and last, we get the first and last we get T1 divided by cos B equal to W by sin C. This is equal to W by sin C. Now, this means T1 equal to W cos B divided by sin C. W cos B divided by sin C. This means T1 equal to W. What is cos B? C square plus A square minus B square divided by twice CA. What is sin C? C by sin C equal to twice R. Sin C will be equal to C divided by twice R. Since C by sin C equal to twice R. A by sin B equal to B by sin B equal to C by sin C equal to twice R. Now, this means that T1 equal to W into C square plus A square minus B square divided by twice CA into twice R divided by C. Twice R divided by C. These two will be cancelled. Now, this means that T1 equal to W C square plus A square minus B square divided by C square A into R. Suppose this is number 1. Suppose this is number 1. Now R. You see. In the question, you see A, B, C, delta have usual meanings. What is A? In a triangle ABC, small a is equal to BC, the side BC of the triangle ABC. What is B? The side CA of the triangle ABC. What is C? The side AB of the triangle ABC. And the delta stands for the area of the triangle ABC. You know that. What is the area of a triangle? Area of a triangle equal to half into product of any two sides into sine of the included angle. Let me remind you. Suppose this is a triangle ABC. This is a triangle ABC. What is the area of the triangle? Area of the triangle equal to half base into all this u. Half into base. Base means this BC equal to A. All this u, suppose this all this u be AB. Half base into all this u. This is equal to half into A. What is AD? Equal to AB sine of angle B. AB sine of angle B. This is what is AB? AB equal to C. AC sine B. AC sine B. If you take AD equal to here AC sine C, then also if AC sine C, then delta will be equal to half of A AC sine C. AC sine C. This is equal to half A. What is AC? Equal to B sine C. B sine C. This means that the area of any triangle ABC equal to half into product of any two sides into sine of the included angle. Product of this side and this side, sine of this angle. Product of this and sine of this angle. Product of this and this, sine of angle A. Means half of AC sine B, half of AB sine C, or half of BC sine A. Half of BC sine A. Half of BC sine A. Now, perhaps you have understood this one. Let me remove this. Now delta area of the triangle ABC. Now delta area of the triangle ABC. Half of AB sin C, BC sin A, like that. Suppose BC sin A or AB sin B. You may write any one of these. Half of BC, A by sin A equal to twice R. A by sin A equal to twice R. What is sin A? A by twice R. A by twice R. Since sin A by sin A equal to twice R. Sin A equal to A by twice R. You may write half of AB sin C. For sin C, for sin C, you may write small c divided by twice R. Ultimately, you will get, in any case, ultimately you will get ABC divided by 4R. In any case, you will get ABC divided by 4R. This means delta equal to ABC divided by 4R. This means R equal to ABC divided by 4 times of delta. 4 times of delta. Suppose this is number 2. This is a formula. I have derived it. You may directly use this formula. R equal to ABC divided by 4 delta. Therefore, 1 implies from 1 you will get T1 equal to W into T1 equal to W C square plus A square minus B square divided by C square A. R means ABC divided by 4 times of delta. 4 times of delta. This means this AA will be cancelled. AA will be cancelled. 1C will be cancelled. Ultimately, you will get T1 equal to W and B will be there. C square plus A square minus B square divided by 1C 4C delta. 4C delta. Delta means area of the triangle ABC. Area of the triangle ABC. Therefore, we have proved this one. Question number 4 has also been proved. WB C square plus A square minus. Perhaps you have understood the question number 4 also. Now, finally, I am going to solve the question number 5. Let me remove this one. Let me remove. Finally, I am going to solve the question number 5. What is it? Two forces P and Q acting parallel to the length and base of an inclined plane. Suppose this is horizontal. This is a plane, inclined plane. Inclined plane, the inclination being alpha to the horizontal. P and Q acting parallel to the length and base. This P. This parallel to the base, Q. Respectively, would each of them see this one independently? Suppose a weight W on the plane. Suppose a weight W is here. Weight W is here in the plane. So that means we have to find a relation between P square, P, Q and W. P, Q and W. Suppose R is the normal reaction. R is the normal reaction. According to the question, you may write, let alpha be the inclination of the plane, inclination of the plane with the horizon, with the horizon. This alpha is this. Therefore, this angle will be also alpha. P is acting along the force. P is acting along the plane and along the plane, and Q is acting parallel to the horizontal. Suppose this one. A body is, suppose it is at the point, suppose this is O, C, at the point C. A body is at the point C as shown in the figure. A body of weight W is at the point C. C in the plane. Now two cases arise. The also let me write, let R be the normal reaction. Normal reaction. Reaction at C. R be the normal reaction at C. Now, two cases arise. When the forces P, R and W are acting at C, it will be in equilibrium. And when the forces, instead of P, you replace P by Q. The forces Q, W and R are acting at the point C. Then the forces will be also in equilibrium. Now, case 1. Case 1. When the forces, when three forces are acting, when the following forces are acting, forces are acting. Number 1, the weight W of the body acting vertically downwards. Vertically downwards. Acting vertically downwards. Number 2, the force P acting along the plane. Along the plane. And number 3, the normal reaction are perpendicular to the plane. Acting at C, perpendicular to the plane. At C, perpendicular. This is perpendicular. Perpendicular to the plane. Then, since the forces are in equilibrium, then by Lami's theorem we get, since the above three forces are in equilibrium, therefore by Lami's theorem we get since the forces are in equilibrium, therefore by Lami's theorem we get Lami's theorem we get P divided by the three forces. Consider the forces P, R and W. P divided by sine of the angle between R and W. Sine of the angle between R and W. Suppose this is, it is vertical, it is horizontal. Therefore, this angle will be 90 degree. It will be 90 degree minus alpha. Consequently, this angle will be equal to alpha. This angle is alpha. Angle between R and W, the whole angle is equal to 180 degree. Minus alpha, the angle between this and this will be equal to 180 degree minus alpha. Definitely it will be 180 degree minus alpha. 180 degree minus alpha. This is equal to R by or W by P R divided by the angle between this and this. What is this angle? It is horizontal, it is vertical. The angle this will be equal to 90 degree. Therefore, angle between P and W will be equal to 90 degree plus alpha. Sin 90 degree plus alpha equal to W divided by angle between P and R equal to 90 degree, sin 90 degree. Sin 90 degree. Or P by sin alpha equal to R by, it will be cos alpha equal to W by 1 This means that P by sin alpha, we have to find a relation between P, Q and W. R will be eliminated. Therefore, P by sin alpha is equal to W. This means W by P. This means I am writing. This means W divided by P. W divided by P equal to 1 by sin alpha. 1 by sin. This means W by P. Cosec alpha. Suppose this is number 1. W by P equal to cosec alpha. This is number 1. Case 1, we have discussed. Case 1. Case 2, when the forces, when the following forces are acting. Number 1, the weight W of the body acting vertically downwards. Number 2, the normal reaction R. Acting at C and perpendicular to the plane. And number 3, what is number 3? The force Q parallel to the horizon. Right. Now, since the body is in equilibrium under the action of these 3 forces, therefore by Lami's theorem we will get. Since the body is in equilibrium, or since the 3 forces are in equilibrium, or since the 3 forces are in equilibrium, the 3 forces Q, R and W are in equilibrium. Therefore, by Lami's theorem, we get. Therefore, by Lami's theorem, we get. Q divided by angle between R and W. This angle is alpha. Total angle is 180 degree. Therefore, this angle will be equal to 180 degree minus alpha. This is equal to R divided by angle between Q and W. Sin 90 degree equal to W divided by angle between Q and R. Angle between this and this is equal to 90 degree. This is 90 degree. Therefore, angle between Q and R 90 degree plus alpha. It will be sin 90 degree plus alpha. It will get this one. This means Q by sin alpha equal to R by 1 equal to W divided by cos alpha. W divided by cos alpha. This means Q by sin alpha equal to W by cos alpha. W by cos alpha. This means Q by W equal to cos alpha by sin alpha. This means Q by W equal to cot alpha. Suppose this is number 2. This is number 2. It is cot alpha number 2. Now, cosec square alpha minus cot square alpha equal to 1. This means W by P whole square minus W by iron. It is Q by sin alpha equal to W by cos alpha. Q by W, it should be cos alpha by sin alpha means W by Q. It is W by Q, not Q by W. It should be W by Q. You see, W by Q equal to cos alpha divided by sin alpha equal to cot alpha. W by Q. W by Q equal to cos alpha by sin alpha. W by Q whole square equal to 1. This is equal to 1. Finally, I am writing here. This means W square by P square minus W square by Q square equal to 1. This means 1 by P square minus 1 by Q square equal to 1 by W square. 1 by P square minus 1 by Q square equal to 1 by W square. W by Q should be equal to cos alpha by sin alpha. Therefore, we have solved the question number 5 also. Dear students, perhaps you have enjoyed the class. Thanks for attending the class. Thank you very much. Thank you.